Hey guys, I'm Tomukas1 and I'm back at it with another Godot tutorial playlist. I'm wearing my Hacker House t-shirt because this time we're gonna do some serious hacking. This is not a beginner tutorial anymore. Watch this if you're interested into delving deeper and understanding more core concepts and becoming a really crack dev. So this playlist is going to be about implementing or working with a custom smart contract. But to start off, the first episode, just to soften up the gears, to kind of get into the rhythm, we're going to delve into the custom transaction code and see how do you even send a transaction from Godot. I guess without any further ado, let's begin. This, you see the transaction test. I have the test function in here. And actually there's one little thing I would like to share with you on how you could start off with these little tests. I go to demos and login demo in the login scene, and here you see this is kind of the thing, right? The original demo. I'm going to remove this path to scene that leads to demo select, and I'm going to add this transaction test path, just so that we wouldn't need to create our own login scene for every demo that we make. All right. So now logically, if I go to play this login scene, you will see what happens. I'm going to, when I click login, I will be logged in right into this this thing. And you can see a function has already passed. Okay, so let me show you which function it was. See, it was transaction test with a test script, and the test script was just this: transaction data is await Solana service transaction manager transfer token, and the token we're sending is this one, bonk devnet. This is the mint address of the bonk token. This is the address I'm sending it to, just my random wallet, and this is the amount of the token I want to send. So basically this function kind of does it all in one: send this token to this address and that amount of that token. So now let's try to kind of recreate this transaction function transfer token, and it's going to take 3 parameters. All right, it's going to take the mint address. No, let's do token address. Token address, which is going to be string. It will also take a receiver address, which is also going to be a string, and then amount to send, which is going to be an int. Let's do an int for now. It should probably be float, but let's do int. And it's going to return transaction data. And transaction data is a new kind of function that kind of gives you more information on your transactions. Okay, so the first part that we need to do is we need to set all those important characters, the accounts of the transaction. So first of all, is going to be our sender, because the sender is going to pay for the transaction. All right, so we'll do this. Var sender keeper, Solana service, wallet, get keeper. Okay, so you have that once you logged in. You're able to fetch this. We also need sender account, and this is going to be a pub key, which we say is Solana service, wallet, get pub key. Is that kind of clear? So there's also going to be receiver account, pub key, which is going to be pub key new from string receiver address. So it's basically going to turn this address into pub key, which is then usable for all the different things. And the last thing we need to do is var token mint, which is going to be a pub key. It's basically, we're just going to move the token address into its own pub key, because accounts, tokens, everything is a public key. And this is also going to be pub key new from string, token address. All right, so now we have all the essentials that we can work with. There's also very interesting thing about how you do the transactions. No, not how you do transactions, but how you hold the tokens. So Solana, it's a very simple thing, right? With Solana, you just hold a token and that's it. You just have your own account, your wallet, which holds the Solana. And with any other token, it's going to look something like this. So let's try to get its information. Solana Explorer does it better, so let me just kind of move it to transaction here. So now you can see right here, this is the address, but this is the address of the account token. So the owner of this token account, it's called associated token account. The owner is my wallet, and the token mint is this bonked, right? Bonked DevNet, okay? And the most interesting thing is that I'm holding it not in my dev wallet, this bonk, but I'm holding it into associated token account. So if for example, I'm sending a token of bonk to some other wallet, I need to first make sure that they have this associated token account that I can send it to. If not, I need to create this associated token account, which costs a bit of Sol, and then I put the bonk into that token. So for every token that is not Solana, you don't hold it directly in your wallet, you hold it in your token account. It's quite a hard concept to understand, but when you get it, you're gonna get it. Anyway, what I wanted to get to is that we need, if we want to kind of send these random token, we need to use both associated token accounts of the sender and of the receiver. So let's see how we can use them. So var sender ATA associated token account, which is also going to be a pub key. We can say Solana service. I think it should be a wait. No, probably not a wait. Solana service create. Is it create? Get associated token account, and this is the address to check. So we have the sender account, so we're checking this to string because it requires a string. And for which token would we like to get the associated token account? That's going to be the token address. So we're gonna get the associated token account of this address. Oh, it does require a wait. So we need to await to get it returned. I'm not going to check whether if the user has one or doesn't, because if they want to send a token, they must have this associated token account. So for that, we don't really pay too much attention. However, we do pay attention to the receiver's associated token account. Now, this is how we're going to send a transaction. We have var receiver ATA, which is also going to be a pub key, and we can also do the same thing. Await, let's just copy this thing because we're also going to need it. Get associated token account of the receiver, but this time we're going to say receiver address. We need receiver address and the token address. And now we need to check if the receiver actually does have, if he has some of that token. If not, we'll need to create the associated token account, and that is going to be the first instruction. So maybe we can actually do it like this. Var instructions, and is going to be an array of instruction. There's also another thing with instructions. So when you send a transaction, it comes like a bundle of instructions. So if the receiver does have an associated token account, the only instruction we're going to add into the instructions is going to be of sending that token. But if the receiver doesn't have an associated token account, there's going to be two instructions. One for creating the associated token account, and the next one to send the tokens to that account that was created previously in that instruction. All right? So now we need to add instructions, and we need to check if receiver does have this account. If receiver ATA is null, then we need to instantiate it anew. Receiver ATA is pub key, create, I think, new associated token account address. The wallet address for this is going to be the receiver address. And the other part, the token mint address, is going to be the token mint. Oh, I'm sorry, this asks for receiver account, not address. It takes in pub keys. And there's also going to be a token mint here. So the new associated token address is going to be derived from the receiver account and the token mint. All right, but it still doesn't exist yet. We need an instruction to create it. We just now derived it, and now we need to kind of to create it. It's quite difficult, but please hang in there with me. So we need to add an instruction. So var ATA initialize instruction, Ix is instruction, is going to be an instruction type, and we'll say associated token account program. This is like the convenient function that we created. Create associated token account, and there's some parameters you need to add to make it work. So who's going to pay for this associated token account? It's going to be sender key pair. Oops, sender key pair. for which account we need to create it, and that's going to be the receiver account. For which token, let me check. Yeah, mint address for which token, for this token that we want to send. And the last one, which was the last one? Token program ID. So the token program ID we can get from Solana service. Solana service.token program ID. So this is the program, this is a smart contract that does everything with tokens. So this is what's going to create this associated token account, this program. All right, and now what we need to do is we need to add this instruction. We still haven't created, we just created an instruction which we're gonna put into the transaction to send, all right? So we can say instructions, append this ATA init instruction. So now we have one instruction in case the receiver account doesn't exist. If it does, this is gonna just skip, and there's also only gonna be one instruction. So we need to now send the token. With sending the tokens, every token has its own decimals. So I can look at the bonk DevNet. You can see it has 5 decimals. All right. That means if, for example, I want to send 50 tokens of bonk, like I did here in this example right here, right? If I want to send 50 tokens, I'm sorry, right? If I just enter right here into the send transaction, I want to send 50, it's going to send 0.00005. Basically means it's kind of difficult as well, but like decimals is how many decimal points your token has. So it's a little confusing, but you're gonna learn it eventually. So let me just kind of go through of how it kind of works. So we need to get how many decimals does this token have. So we can say it decimals, token decimals. It's always going to be an integer. We can say await Solana service get token decimals, and we're going to put in this token address right here, right? Because it takes the address. I should probably like change it to be mint instead of strings to kind of make it like unify it more, but I'll do it later on. Okay, so now we should now have how many token decimals this token has. Decimal amount, because whenever you're sending tokens, you're not sending the token, you're sending the decimal amount of that token. So decimal amount to send, the decimal amount is always going to be an integer. We're always going to send the decimal amount in big numbers. So that is going to be the amount to send times POW, the 10 to the power of token decimals. What this means is that this power means power. So basically the amount to send is going to be 10 powered by token decimals. So for example, if I want to send 50, I need to multiply 50 by 10 times that decimals. Basically, if I want to send 50, I'll need to send it times, because there's 5 decimals, I need to send it, multiply it by, add basically 5 zeros to it. So if I do 10, what about if we do maybe like this, 10 raised by 5, see, it gives me 5 zeros, 1 with 5 zeros, all right? So this is what a POW does. It gives you 10 powered by this amount, so you see 100,000. And what we'll need to do is the amount that we want to send, so for example 50 times this amount. So I'm going to be sending this amount in Lamports with the decimal account. See, so every time you're sending tokens, you're sending Lamports instead of the actual account, instead of the actual amount. So let's do it. We now have the decimal amount, and the last thing we need to do is, well, not the last one, we need to create instruction for sending the transaction. We'll say var transfer instruction, which is also going to be an instruction. We'll say it is token program transfer checked. So this basically is an instruction for transferring Solana SPL tokens. And this is going to require a couple of things. So one of them is source pubkey, from which account are we sending? So interestingly, we're not sending it from sender account, we're sending it from the sender associated token account. All right, we're sending it from the account that holds those tokens. Next off, mint pubkey, which token we want to send. This is going to be this token mint. Next one, destination pubkey. Destination is going to be receiver ATA. This is the account that's going to receive the tokens, not the receiver account, but the associated token account. Who's going to pay for this? this is going to be sender key pair. Then the amount we want to send, this is going to be that decimal amount, that Lamport, maybe let's call it Lamport amount. Lamport amount, all right? We send Lamport amount. And then decimals, we already put all those decimals in here, so let's write 0. And what we'll need to do is instructions, append, transfer instruction. So now we have either 1 or 2 instructions, all right? And now there's only one last thing to do, is to send the transaction and wait for it to return. So what we'll do is this, a var transaction data, which is going to be of transaction data, await Solana service, transaction manager, send transaction thing, or sign transaction. Yeah, sign transaction. We need to sign this transaction. Basically, this function, what it's going to do is going to force in your browser for the extension to pop up so you can sign whatever this transaction was. All right, so, and the transaction comes up with an array of instructions. So that's what we're going to put in, instructions. Okay? And here we have it. Now we are waiting for the transaction data, and what we're just going to do is we're just going to return the transaction data. And that's it. So we'll know if it worked or it didn't work. So now we have transaction data, and I think we can just, there's one more thing we need to do, is we need to say that this is not this function, but rather just transfer token, right? Because we just remade that function into like this one from scratch. Okay, so wait token from this bonk devnet token, we're sending this token to this account, and we're sending 50 of it. Let's see if this actually worked. Guys, fingers crossed, and let's try it out. Decimals different from mint decimals. Something is not right. We need to try and now debug it. Oh, my bad. I remember what it is. I don't write in 0, I write in the amount of token decimals that this token has, because it's a program, it needs to know all those things. All right, I'm sorry for the confusion. Let's try it one more time. And signed, and we have a transaction. A transaction success. We have sent 50 bonk to this account, and you can see right here, even though we send this token and we send it to this DSJ. Okay, so you see owner is this HNG, which is the account we wanted to send to, right? Each HNG. But we didn't send to it, we sent it to this token account, DSJ, which was created in the process. Ooh, now this was a long ass tutorial. But I really hope I didn't lose you. I hope you kind of understood. I know there's a lot of stuff, like blockchain isn't easy. This stuff you're gonna learn. I still have no idea like half of the things I'm doing. It just sometimes works, sometimes doesn't. You just need to do it. You need to kind of to grind. I don't know what to tell you. But I'm sure that with time, with effort, you're gonna become a professional at this, and you're gonna become better than me, and you're going to submit all the proposals to Godot SDK because it's open source, and let's all build it together, you know? Anyway, this was the part 1, just getting to know this whole environment, and with the next episode, we're finally gonna be trying to integrate that smart contract. So I really hope to see you there. I really hope you're not bored with me. So bye-bye. See you in the next episode.